Alrighty, friends. Well, this morning we have a fraction equation, and we're trying to determine what the value of 3/4 plus 6/8 is, right? And so the first thing I like to do is kind of like think of the fractions that I'm being asked to put together. And so because my numerator is less than the denominator, do you think that's going to be greater than 1 or less than 1? Yep. So I have a fraction that is less than 1 whole, I should say. Same thing with 6/8. Because my numerator is less than my denominator, we have another fraction that's less than 1. So our objective here is to figure out what these two fractions equal to when added. However, because I have denominators that are not alike, right, then I need to figure out a way to do this, to do the math in regarding to being able to either convert either one of these fractions so that I get a like denominator. And so the best way I could kind of think of this is just to rewrite 3/4 and to rewrite 6/8. And I look at the denominator in each and I list my multiples. I know I've showed this to my group using skip counting, right? So really quickly, after 4 we have, if we're skip counting, we have 8 and then we have 12. Vice versa, if I have 8, if I continue to skip count by 8, I have 16 and then 24. These are the multiples, right? However, just by looking and comparing the denominators, I want you to notice that we already have a common denominator, right? And because 8 and 8 are the same, that's the denominator we're going to stick with, right? And so now it's a matter of converting 3/4 so that it is equivalent. We want to find an equivalent fraction where I have 3/4 is equivalent to a fraction that has a denominator of 8. So the way I like to set this up is I like to rewrite the 3/4. I like to show its equivalence. And then I want to make sure that my denominator is 8. And so I think of this regarding the numerator, right? Denominator. Denominator first. I'm going to have the denominator times a factor is going to give me a product of 8. And so 4 times what gives me 8? You're thinking with me. 4 times 1, 4 times 2, friends. Yep. Alrighty. And the same thing, always remember, whenever we're coming up with an equivalent fraction, whatever we multiply the denominator by, we need to multiply the numerator by. And so, same thing. 3 times 2 equals 2. 6. Awesome. So now that I have 3/4, which is equivalent to 6/8, and I have my original other add-in, which was 6/8, now I can finally put them together, right? So I didn't need to change 6/8 just because, remember, I was sticking to 8 being my denominator. And so this is my original fraction, and now this is my other fraction that I'm adding together. And I'm going to do this by rewriting my fractions. Please remember, friends, that when we add fractions, we don't need to add the denominators. We only add the numerators. And so 6 plus 6 is, 12. And my 8 stay the same. Well, here's the part where if I'm adding two fractions with related units, my related units in this case are my common denominators. I didn't have any mixed numbers, right? I wanted to make sure that I'm going to now use this information to create a, say with me, number bond, right? And so, before you continue with the step though, think about it. Why is it that I might want to utilize a number bond in order to determine what 12/8 is? How do number bonds help us, right? And so, give it some thinking time. Ready? 5. I want you to think of an answer. How is it that number bonds can help us express this number or this sum better? Okay? Now, if you notice, my sum has a numerator that's greater than the denominator. What does that tell me? Is the value of my fraction going to be less than 1 or greater than 1? Yep. So whenever your numerator is greater than the denominator, then the value is greater than 1. And so the first thing we want to do is we want to turn this 12/8 into a number bond that can help us express any whole numbers that are in this fraction. And so a whole in fraction terms is when the numerator and the denominator are the same, right? And so example, starting with 2/2, right? Same thing as a whole. If we continue the pattern, then we have 3/3, we have 4/4, we have 5/5, 6/6, and so on, right? And so that's the same thing I want to do with 12/8. I want to first pull out any wholes I have. And so 8/8 plus what gives me 12/8? So if you need to count up, 9/8, 10/8, 11/8, 12/8, yep. That's 4/8, friends. And so using that information, I can determine and express my answer, right? I can express my sum as a mixed number. So if we refer back to our criteria of success, I'm using a non-visual model, I'm using a number bond, and now I'm going to express my answer as a mixed number. Mixed number meaning, it was part of our definitions this morning. Any wholes with fractions to get a better understanding of the quantity of something. And so 8/8 becomes 1 whole, and 4/8 becomes what remains to the whole, right? So it's 1 and 4/8. And that pretty much sums up how to add up two fractions that initially, right, we needed to make sure they were a little more related by making sure that they had a common denominator. And then we use a number bond to kind of help us sort out the information and come up with a mixed number. So 1 and 4/8. Alrighty? In the next video, you're going to notice this same work. However, we're going to go backwards and use a visual representation to do the same work, okay?